Hi guys, welcome back to my channel, and really appreciate for finding time to click on this link. So today we're going to tackle the Enterprise Networking Project 7. Alright, and we've covered Project 1 all the way to the 6th Enterprise Networking Project. And suppose you've not watched the videos or the projects, I will leave a link on the description part of the video or the first comment. Click on the links and start from Project 1 all the way to the 6th Enterprise Networking Project. Then come and watch this video, which is the Enterprise Networking Project 7. And another method of accessing the videos, go to our channel, Gurutech Networking Training. Okay, then under playlists, just click on the playlists and scroll down. Then you'll find a playlist with the name Enterprise Networking Projects. Click on the playlists, and here are the videos that we've recorded so far. We started from a very simple Enterprise Networking project, which was Project 1. Then the complexity was increasing as we moved on. Okay, and also if you're new to this channel, or even if you have not subscribed to our channel, kindly do us that favor, click on the subscribe button, hit the bell icon so that YouTube will automatically notify you when you upload new projects. Okay, also you can like our video and share with friends. Okay, alright, so guys, without any further ado, let's begin Enterprise Networking Project 7. Alright, so we had a case study here. I'll open the case study and start reading so that we can analyze, design and implement this network together. Okay, we have a 2-page case study here. The first page is just a description, and the second page is about the requirements, right? So it's Enterprise Networking Project 7. Alright, so guys, Melbourne Health Services is a well-established health provider in Australia which offers health solutions and services to its clients. The institution operates in 2 locations within the same city, having the hospital headquarters 20 kilometers away from the branch hospital. Therefore, it has the following departments within its main headquarters: medical lead operation and consultancy services, medical emergency and reporting, medical records management, information technology and customer services. The branch hospital was designed to share the workloads with the headquarters, hence it contains the following departments: nurses and surgery operation, hospital labs, human resource, marketing and finance. Each location is also expected to have a guest or waiting area for patients or visitors. Alright, so far the network was using third-party services to maintain its IT services. The senior management has decided to own their network infrastructure, included local area network, wide area network and a server-side site that is expected to be located separately at the headquarters and is connected to the HQ routers with an access switch. The server-side site will host DHCP server, DNS server, web server and email server. Okay, the network is expected to be cost effective and observes the information security rule of CIA: confidentiality, integrity and availability. The network is expected to have a hierarchical model with 2 already purchased core routers, one at HQ and another at the branch, each connecting to 2 subscribed internet service providers. Okay, due to security requirement, it has been decided that all the departments will be on a separate network segment within the same local area network. Okay, you have been hired as a network security engineer to design the network according to the requirements set by the senior management. You will consult an appropriate robust network design model to meet the design requirements. You will also implement access control lists and virtual private network to enable secure communication, considering security and network performance factors paramount to safeguarding confidentiality, integrity, and availability of data and communication. The network security policy will comprehensively dictate the user's access to each site using access control list. So guys, this is a very important project. Then on the second page we have network design and implementation requirements. So let's see our requirements. We have almost 21 requirements. This is a long project, you know, so that's a good number of requirements for your study and understanding. So number 1, use Cisco Packet Tracer to design and implement the network solution. Use hierarchical model, providing redundancy in the network. Both HQ and branch routers are expected to be connected using serial connection. As mentioned earlier, for network cost effectiveness, each site is expected to have one core router, 2 multi-layer switches, and several access switches connecting each department. Very important. Each department is required to have wireless network for the users. Every department in HQ is estimated to have around 60 users, while in branch is estimated to have 30 users. Each department should be in a different VLAN and a different subnetwork. Provided a base network of this one, carry out subnetting to allocate the correct number of IP addresses to each department. Very important. The company network is connected to the static public IP address of this one, right? Connecting to the 2 ISPs. Good. Configure basic device settings such as hostnames, console passwords, enable passwords, banner messages, and disable IP domain lookup. Okay. Devices in all the departments are required to communicate with each other with the respective multi-layer switch configured for inter-VLAN routing. The multi-layer switches are expected to carry out both routing and switching functionalities, thus they will be assigned IP addresses. All the devices in the network are expected to obtain IP addresses dynamically from the dedicated servers located at the server room. Okay, DHCP server. Devices in the server room are to be allocated IP addresses statically. Very important. Use OSPF as the routing protocol to advertise routes both on the routers and multi-layer switches. Configure default static routing to enable routers and multi-layer switches to forward any traffic that does not match routing table entities. Use next op IP addresses. Okay. Configure SSH in all the routers and layer 3 switches for remote login. Configure port security for the server side department switch to allow only one device to connect to a switch port. Use sticky method to obtain MAC address and violation mode of shutdown. Configure extended access control rule together with site-to-site VPN in bracket IPsec VPN to create channel and encrypt communication between HQ and the branch network. Configure port address translation to use respective outbound router interface IP address and implement the necessary access control rule. Test communication and ensure everything configured is working as expected. Guys, this is a very interesting project and a very important project because on our previous projects we've added a lot of technologies here now. Okay, for example, VPNs. We're going to configure IPsec VPN and other technologies also. Okay, and we've seen also a server site location is separately from other locations, okay, and so on and so forth. So guys, what you need to do is to start analyzing this case study and design the network, after which we'll start implementing that network based on these requirements here. Okay, so we have a company here. It has 2 branches, and we've been told to be cost effective, each branch should have 1 core router, 2 multi-layer switches, and several access layer switches, and each core router should be connecting to 2 already subscribed ISPs here. Okay, and also there's another important point here that I saw. Server set is expected to be located separately at the headquarters and is connected to the HQ router with an access switch. The server set will host these servers, okay, and so on and so forth. So guys, I'll go back to our packet tracer. Guys, we have analyzed this network and seen that each location has 1 router, 2 layer 3 switches, and several access layer switches. Okay, and to save time, guys, I already designed something here that can help us, as you can see here. So this is what we're going to use to design our network on packet tracer. So as you can see, we have HQ network on the left, branch network on the right, ISPs on top, and server side site at the bottom. Okay, and between the 2 routers we have created a tunnel that is called IPsec VPN tunnel, site to site VPN tunnel, okay, to encrypt all the communication from branch network to HQ network, and also to encrypt all the communication from HQ network to branch network. So guys, this is what we are going to use to design the network on our packet tracer. I did it earlier to save time, but it's very simple. It's self-explanatory. We've been told that each location has 1 router, this one has 2 multi-layer switches and several access layer switches connecting to each department. Okay, then a server site location is connected directly to HQ network with HQ router, okay, using access layer switch, this one, very simple, and each router is connected to 2 ISPs for redundancy. So guys, let's go back to our packet tracer and design this similar network topology there. Okay, all right. So guys, for routers I choose 29 routers. Let me put it somewhere here. That's the first router, and our second router, let me put it there. Okay, and 2 multi-layer switches. For multi-layer switches, choose 3650, put there, also put here. $36.50. Okay, and we have 2 ISPs, so let's assume we had 2 ISPs. So let's assume we had ISPs. I'll try to choose 2811 routers. Let's assume 2 of them. Okay, and also so I'm just going to connect distribution layer to the core layer, okay, and connect the core layer to the ISPs. So I'll do it very fast. Choose automatic. Okay guys, so also before I may begin connecting these devices, we've been told to use serial connection between HQ router and branch router. Okay, so we need to choose serial with the DCE, and when we try to choose that one and click, there is no serial interface. So what we do, we just click here and turn off the router. There's something like a 0 here. Just click it and drag this model, press there and turn it on again. You do the same to this one also. Okay, so I'll connect them. Okay, all right, so let's connect these routers to ISPs, and I'll just use I'll use serial again. I'll use serial. So here also we go back and guys, we've been told that each router is connected to ISPs. So for the second connection, we need to include another serial interface, and as you can see, we only had 2 serial interfaces on the routers, so we need to include another module also. Okay guys, so we've connected the core routers to ISPs. So what I'll do is connect the routers to layer 3 switches. It is very important also, and for that one I'll use automatic. Just click automatic. Okay, so let's go back to the topology that we implemented, that I implemented earlier. So also the core router at the HQ is connected to a layer 2 switches, a layer 2 switch that is connecting to server side devices. So I will include a layer 2 device here, layer 2 switch somewhere there. Alright, so let's connect access layer switches to the distribution layer. Okay, as you can see, each location we had how many departments? 1, 2, 3, 4, 5, 6. So I'll go back to our case study and see. HQ we had 1, 2, 3, 4, 5. Then we were told each location is expected to have guest or waiting area. So we had 6 departments. Okay, and so I'll include 6 access layer switches on each side. Do it very fast. Okay guys, so I have included all the access layer switches as indicated here on our topology that you are referencing. Okay, so what I'll do is connect them very fast to layer 3 switches. Okay, so make sure you connect each access layer switch to 2 layer 3 switches. Okay, and I'll start and do it very fast. Okay guys, so as you can see, we have connected the access layer to the distribution layer, and as you can see, we have implemented redundancy as required in our requirements, and it looks like our topology that we implemented earlier. So what we've not added is just the devices and to separate the locations. For example, this is HQ, branch network, ISPs, and server side. So I'll do that very fast. I'll add devices, and for the device that we'll add, I will add one printer, one PC access point, and let's say a computer or a smartphone. Okay guys, so I have placed all the devices as you can see. So what I'll do is just connect all of them I'll connect all of them to each switch. So I'll do it very fast to save time also. Okay, so let's connect the server site. I'll include how many servers, 4 of them. So I'll do it very fast. Okay guys, so we are done connecting all the devices. As you can see, we have created all the layers and connected each and every one of them, with the access layer taking all the host devices. Okay, and if you compare to our initial topology, you can see a resemblance: HQ network, branch network, ASPs, and the server side. So what I'll do, guys, I'll do the naming first. The first thing I'll do is just to reset so that we can have the actual size. Okay, so this is our topology so far. This is our topology so far. We have the branch network on this side and the HQ network on the other side, right? So what I'll do, just to do naming, I'll do it very fast to save time. For example, this one will be HQ router, okay, and this one will be branch router. Okay, so let me do for the layer 3 switches. Okay, then for the access layer switches, I'll do it very fast, save time. For the access layer switches, I'll name according to the departments. For example, we had medical lead operation and consultancy services, MLOCS. Okay, right. Okay guys, so I have named all the access layer switches, distribution layer switches, and the core routers. So let me just say this is ISP1 and this is ISP2. Okay, so what I'll do very first also is to name the devices. Okay, all right. Okay guys, so as you can see, I've named all the devices in the network, including the access points, the host devices, and the intermediary devices. For example, the routers, the layer 3 switches, the access layer switches, etc. So the second step that we're going to do is just to turn on the devices, the layer 3 switches and the routers, so that we don't have any red icon indicating on the links. Okay, let's start with the routers. Click on the routers and come to config, and this serial interfaces just turn on. This one also turn on, close, then come to config, turn all the serial interfaces. Okay, then come to the routers and turn all the serial interfaces there, plus the gigabit Ethernet. Okay, so we go back to the layer 3 switches. For layer 3 switches, you're just going to add this power supply. We just drag AC power supply to this empty slot. Okay, then you close. Okay, so we are done. and we're just waiting for them to turn green. Okay, all right. So meanwhile, we can just separate the borders, and let's say this is the branch network, this is this is the HQ network, this is the branch network, and finally this is server side. Okay, so before I do that, what I'll do, just to minimize so that our diagram looks smaller. Okay, so we can just draw the pellets when this thing is small like this. Okay, you can just draw the pellets when it's small like this so that you can see it clearly. Just say no fill. Okay, drag this here and take it somewhere there. Yes, somewhere here. Also on this side also to somewhere there. Okay, then at the server side, make it somewhere there. Okay, all right. So what I'll do, just adjust a little bit and reset. Okay, so as you can see, we have all of them here. So I'll do the naming very fast. Okay guys, so I think all of that is done, and a little bit of this. Okay, so I just take it up a little bit. Okay guys, so as you can see, we have our HQ network here, branch network here, and the server side is here. Okay, and what I'll do is to divide every department and name it, and for that I'll be using also different colors. So I'll do it very fast to save time. Okay guys, so I think we've finished on making the diagram look very beautiful and separating the various borders or the departments from each other, and we can easily identify which department are these. So I'll just minimize a little bit of maximize, and as you can see, our topology is now looking very beautiful. And what I'll do is just to name the departments very fast. Okay guys, so guys, we are done naming all the departments, both at the branch network and on the HQ networks. Okay, alright. So guys, basically we need to go back to our requirements and begin reading some of the technologies that we are going to implement here. Okay, alright. So let's go back to our requirements. Okay, so this is the project, and on the requirement side, we are required to implement several technologies, and as we have read earlier, we are required to implement VLANs, to configure basic device settings, routing technologies, for example OSPF, NAT, inter-VLAN routing, DHCP server, SSH, access control list, VPN, and port address translation. So guys, to save time, I have already drafted a configuration guide that will guide us through all this process. Okay, so this is our configuration guide that we're going to follow. The first step will be network design and beautification, of which we've done here, as you can see, this one. Then the second step will be basic settings to all devices plus SSH on the routers and layer 3 switches. Okay, then number 2 will be VLAN assignment to all access VLAN assignment plus all access and trunk ports on layer 2 and layer 3 switches. Then number 3 will be switch port security to server side site department. Okay, then number 4 will be subnetting and IP addressing. Number 5 will be OSPF on the routers and layer 3 switches. Number 6 will be static IP address to server room devices. Okay, number 7 will be DHCP device configuration. Number 8 will be inter-VLAN routing on layer 3 switches plus IP DHCP helper addresses configuration. Number 9 will be wireless network device configuration. Number 10 will be site-to-site IPsec VPN. Then number 11 will be default static route. Then number 12 will be port address translation plus access control list. And finally, we'll verify and test our communication. Okay, guys. So, guys, without any further ado, let's begin the first configuration, which will be basic settings to all devices plus SSH on the routers and layer 3 switches. And guys, I always approach a kind of configuration. I configure one device, right? Then I do configuration on I write the commands on notepad and copy to all other remaining devices. Okay, so I demonstrate with one device, then for the remaining devices I copy code, I write codes on commands on notepad and copy to all other remaining devices. Okay, so let's demonstrate with this one. Enable, that's first command, configure terminal. Then we need to configure what kind of settings. We need to configure hostname, console password, enable password, banner message, and to disable IP domain lookup. Okay, so hostname. Let's say this is medical lead operation and consultancy services. That one. Switch. Okay, then enable password, let it be Cisco. I'll use Cisco for all the passwords that are in this configuration. Okay, then also no IP domain lookup, no IP domain lookup. Okay, then banner message, banner MOTD, 2 characters. Inside the character, let's say no unauthorized access. Okay, right? So line console password, line console 0. Let's say password to be Cisco also. Then authenticate login, then exit the line interface, right? All right, then what else? Let me check what's remaining here. Okay, I think we've configured all the things. So what's remaining is just to configure service password encryption to encrypt all the password that we've just configured right now. Okay, so service password encryption. Okay, so I believe we've configured everything as required. Hostname, enable password, no IP domain look, banner message, line console 0 password, and service password encryption. Okay, all right. So guys, I will open notepad, and let me close this one and copy commands and write commands here and copy to all other remaining switches. Remember, we have a lot of switches here, almost 9 of them. I mean 13 of them. Okay, So first command is enable config t. Okay, then enable password, enable password to be Cisco. I'll use Cisco for all the passwords. Then banner motd, 2 characters. Inside the 2 characters I'll just say no unauthorized access. Okay, and then what else? No IP domain lookup, no IP domain lookup. Okay, then line console 0, password to be Cisco, then authenticate login and exit the line interface. Okay, then also what else is remaining here now? Let me check what I configured here. Service password encryption. Let me just copy this one first. Copy, close this one, and I paste. Okay, alright, so I believe we have configured all the required basic settings to the first switch, and for the remaining switches I'll copy these. And I have realized that I have not configured host name to be this is the second one is medical emergency and response department, which is MR switch. Okay, alright guys, so for these remaining switches, what I will just modify is just host name. All this configuration will remain the same. Okay, so let's go very fast guys to save time. Okay guys, so we are done configuring the simple basic configurations on the layer 2 switches, and let me just open the config guide also again, plus the routers and layer 3 switches. So I'll proceed to layer 3 switches, and guys, we've been told on the layer 3 switches we need to include SSH, okay, plus the routers. Okay, alright, so guys, we'll do that one very fast on the first device here, and write commands for the other devices and copy. Okay, alright, so what I'll do, this is multi-layer HQ multi-layer switch. I'll just modify here to be HQ multi-layer. Okay, switch, copy, right, then I paste. Alright, so guys, I've configured the basic settings. So what I'll do is to configure SSH on this switch. The first thing to do when you're configuring SSH, you configure domain name. So you say IP domain name to be, let's say, cisco.net or cisco.com, right? Then you configure username and password. Username to be admin and password to be, let's say, Cisco also. Okay, Cisco, good. Then what do you do now? Crypto, we generate crypto keys, crypto key, generate RSA, then modulus length of 1024. Okay, alright, then you enter line VTY 0 to 15. Good. Then you say login. To use the local database, you say login local. Okay, then to allow only SSH to be used as a remote login method, say transport input SSH. Okay, exit and do right. Okay, so we've added SSH on this switch, and we'll proceed toward SSH and basic settings to all other remaining devices in the network except the ISPs, because let's assume the company, the ISPs routers are being maintained by the internet providers. Okay, alright, so I'll go to our notepad and include SSH configuration here. So we've configured the first switch, so the second switch will be my HQ multi-layer switch 2. Okay, then SSH. How do we configure SSH? Create domain name first. Okay, IP domain name to be cisco.net. Then you hit enter. Then you create username. Let's say admin plus password of Cisco. Okay, then you create crypto key generate RSA. You hit enter, then you input a modulus length of 1024, then you enter line V2Y 0 to 15. Okay, then you say login local, then transport input SSH, exit, then do right. Okay, so I'll copy this to the second switch, and for the other remaining switches, what I'll just modify is just the host name. Okay, very simple, guys. Okay guys, so we've configured the basic setting plus SSH to all the layer 3 switches. So what's remaining is just this router and this router. Basic setting plus SSH. So it's pretty much simple. What I'll do, just to modify and say this is HQ. Let me read it again. HQ router, branch router. Okay, so just host name that will modify, and we move on. HQ router. Okay, and we copy. And for the branch router, we'll just modify host name, and everything remains the same. Alright guys, so basically the basic settings plus SSH is done for all the devices, the routers, multi-layer switches, and access layer switches. But we said on ISP routers, we assume that internet providers companies are responsible to configure them. Okay, what we'll just configure is just IP address to test our communication. Okay, alright, so let's go back to our configure steps. Step 2 says that we configure VLANs plus access and trunk ports on layer 2 and layer 3 switches. Okay, very simple. For example, let's say I've not included VLANs. So guys, I'll include VLANs very fast. For example, this will be VLAN 10, 20, 30, 40, 50, etc, etc. So let me do that very fast. What I'll do first, let's say this is VLAN 10. Okay, so let me do it fast to save time. Okay, so I have included a VLAN number for each department. As you can see, we have until VLAN 130. Okay, so what I'll do is to configure VLANs and assign ports, roles of access, and trunk ports. So guys, if you analyze this topology here, let's start with this switch. For example, this switch is connected to layer 3 switches, and access, host devices, right? So any connection or any link between layer 2 switch and layer 3 switch here will be trunk interface, but any link between this access layer to the host devices on this side, these devices will be access interface, access port. Okay, and we must assign a VLAN number to that port, and the same will apply to all other remaining 12 switches. Okay, so let's start with this one. And I always have pattern of connecting ports. For example, I believe this is FA0/1 and this one FA0/2, and that pattern is across all the devices. Okay, Alright, so let's begin. So Cisco, enable Cisco. Alright, config T. So let's start. We need to assign these two ports, which is FA0/1 and FA0/2, to be trunk interface. So let's say interface range FA0/1 to 2. Okay, switch port mode to be trunk. Okay, good. Then you exit. Then all the remaining interfaces to be access interfaces, access ports. Okay, so interface from 3 to 24. Remember, a switch has how many ports? 24 first Ethernet ports and 2 gigabit Ethernet ports. So I will not consider the 2 interface switches gigabit Ethernet ports. I'll just work with first Ethernet ports. Okay, switch port mode access, then switch port access VLAN 10. Although I didn't create VLAN 10, I'll do it again. I'll do it later, I mean. Okay, exit. So let's say VLAN 10. What you do first is to create the VLAN number, VLAN 10, and name it. Let's say the department LSML course. Okay, exit. Alright, so we've configured the configuration. We have configured this switch to have trunk and access interfaces assigned to a VLAN number. Okay, and the name of the VLAN will be called MLCOS as per the department. Okay, alright, so let me just close this one and proceed to write commands on Notepad and copy to all other remaining switches. Okay, so what I'll do here is just to delete everything, and for the second switch here, we need to assign to VLAN 20 the interfaces that are connecting to host devices. Okay, so the first thing that we do is to create VLAN 20 and name it as per the department, I mean. Okay, name to be MER. Okay, then exit the VLAN interface. Okay, then interface range first Ethernet 0/1 to 2. This one and this one. Switch port mode to be trunk. Okay, because they are connected to layer 3 switches. Okay, alright, so exit the 2 interfaces. Then also I'll just try to copy this one, copy. Then interface now from 3 to 24. Switch port mode access, then switch port, copy again this one, switch port access, switch port now access VLAN 20. You exit, right? Then now for the remaining switches, what I'll just modify is the VLAN number, VLAN name. Okay, and switch port access VLAN, the one that we've just modified here. Okay, alright, so let me do it faster to save time also. Okay guys, so as you can see, we've configured VLANs to all the switches, plus assigning ports role of access and trunk ports. And on our config steps, guys, we were directed to configure VLAN assignment to plus all access and trunk ports on all the layer 2 switches and layer 3 switches. So guys, we've done for layer 2 switches, so we proceeded to layer 3 switches. Okay, so for layer 3 switches, guys, we're just going to assign VLANs plus ports roles of trunks. Okay, because when you analyze this topology here, we want the interface that is connecting to the routers to be a routed port. Okay, meaning it will be a layer 3 interface. So we won't assign any VLAN to this port, just IP address, but all other remaining ports we assign them to trunk ports. Okay, all right. So for example, this switch here is connected to how many VLANs? Switch 6 VLANs. Okay, VLAN 80, 90, 100, 110, 120 and 130. Okay, so we'll create those VLANs here, okay, and assign these ports roles of trunk. Okay, so I'll start from this side. Okay, all right. So on this switch here, I don't want to input password, so I'll just click there and come and say exit. All right, so we create how many VLANs for this switch, guys? We create how many VLANs? 6 VLANs, 10, 20, 30 until 60. Okay, all right, because it's connected to 6 access layer switches, and each switch is on a separate VLAN. Okay, so click, say VLAN 10, VLAN 10, I want to name them 20, VLAN 30, VLAN 50, VLAN 40, and finally VLAN 60. Okay, exit. So we have created VLAN 10, 20, 30, 40, 60. Okay, all right. So what do? We assign these ports, this one, roles of trunk. Okay, so this is the first one is just a minute. That's gig. It's the first one, which is gig 101. Okay, so from gig interface gig range, range gig 1/0/1/2 now 2, because the first one will be assigned IP address, so it doesn't have to be a switch port, it will be a no switch port. Okay, so this is gig 2, gig 3, and the last one is gig just a minute, the last one will be gig 07. Okay, all right. So gig 2 to gig 07. Switch port mode trunk, exit. So we copy these commands to all other switches, remaining layer 3 switches. Okay, so what I'll do, just create the VLANs. VLAN 10, VLAN 20, VLAN 30, VLAN 40, and VLAN 50, and finally VLAN 60. Okay, then interface range gig 1/0/2 to 7. Okay, switch port mode trunk. Okay, all right. So copy to the second switch, which is this one. Come to config, hit anyone, exit, and hit enter. Okay, all right. So for this side, guys, for this side we'll have how many VLANs? From VLAN 80. Okay, so I'll create the VLANs. So I'll say this is 80, then 90, then this is 100, 110, 120, and finally 130. Okay, sorry, copy, start with this switch, then finally to this one, so you create only VLAN numbers that are connected to that switch. Okay, for example, this multi-layer switch is connected to 6 access layer switches, and those 6 access layer switches are connected to these VLAN, are on these VLAN numbers 80, 90, 100, etc. Okay, so for the server side device, we'll look into what to do with it later. Okay, because it's not connected to a layer 3 switch. So let's proceed with our config steps. All right, so guys, number 3, switch port security to server side department. Okay, so we are going to server side department to configure switch port security. Okay, all right, so how do we configure switch port security? The first command is switch port. Sorry. The first command is to enter the interfaces, that range, this range here. Okay, so I'll copy them. I'll copy and paste. Okay, then you say switch port security, then switch port security maximum. We've been told to just a minute. Let me just open the requirements. Configure switch port security for the server side department switch to allow only one device to connect to a switch port. Okay, use sticky method to obtain MAC address and violation mode of shutdown. Okay, so maximum is only one device. Then switch port security, let's say MAC address to be obtained through sticky command. Okay, then switch port security, violation mode to be shutdown. Okay, then exit, do right, then do show port security. Good, as you can see from FA032 have been configured successfully. Okay, so let's go ahead. Subnetting and IP addressing. Guys, as you always know, subnetting really takes a lot of time, and on the requirements we were given a block here. We were given a block here, 192.168.100.0, okay, to use in this network. And to save time, guys, I'll already design an address table. Okay, I've already designed address table to use in this topology. Okay, and here is our address table. I'll just open it. So this is our addressing table that we have already designed. As you can see, HQ network, we had how many departments? 6 of them, and each department has a network. Okay, branch network, branch hospital also same, 6 departments. Server side same, okay, 1 department. And the network between the layer 3 switches and the routers also is here, and plus the network between the routers and the ASPs. And for the network between the routers and the ASPs, we have given here this one. Okay, so guys, what I'll do is just to include the networks on the diagram here. Okay, so for example on the first department had this network, so I'll just say net to be that one, a subnet mask of /26. okay, because we were told, just a minute, because we were told each department is required to have at least 60 devices. Okay, and /26 notation will satisfy that requirement. Okay, alright, so what I'll do is just to copy to all other remaining devices very fast to save time. Okay guys, so as you can see on the branch hospital, we are told that each department is supposed to have 30 users, and the /27 notation is will satisfy that requirement. Okay, so that's why we've used /27 notation on the branch network and /26 notation on the HQ network to satisfy 60 users, and on this side 30 users. Now on the server side, guys, we assumed that we had at least 10 devices, and we used this network. Let me just include it here, this one, /28 notation. Okay, will satisfy 10 devices. Okay, all right, /28 notation. Okay, all right, so what's remaining, just a minute. So what's remaining is just to include the networks between the layer 3 switches and the routers, and between the routers and the ISP routers. Okay, so I'll do that very fast, save time also. Okay, so I've included the networks on between the layer 3 switches and the routers, and what's remaining basically is to include the networks between the routers and the ISPs. Okay, so I'll do that very fast also to save time. Okay, so guys, we are done allocating the networks at the required interfaces. Okay, as you can now see, we have included networks for every department and between the interfaces. Okay, so let's go back to our config methods and continue. Alright, so number 5 is to configure OSPF on the routers and on the switches. Although we've not configured the devices, but subnetting and IP addressing. So we've not done IP addressing. Okay, so what do we need to do? We need to assign assign interfaces IP addresses. Okay, for example, when we start assigning this multi-layer switch an IP address, we'll assign IP address to this interface. Okay, alright, let's do that very fast. Exit. Okay, so it's this interface that we're going to assign IP address, this one, gig 101. Okay, interface gig 1/0/1, no switch port. If you want to assign IP address to a layer 2 port on a layer 3 interface on a layer 3 switch, then you must make that switch port a routable port. Okay, by issuing a command no switch port to make it a layer 3 interface. Then you assign IP address to be on this network, which will be 192.168.81 now. Okay, 81 subnet mask of 255.255.255.252. Okay, exit, do right. And guys, also, you know, I'll do that in the next then we move on to this switch also. So we want to assign IP address to which interface? This one, gig 101. So interface gig 101, okay, no switch port, okay. Then IP address to be paste that one. Then I check it was 84. Now it takes 85. So it was of 255.255.255.252. Exit and do right. Then we move to this switch. We assign IP address to which interface? This one. Okay. This interface is gig 101. So we are on the right interface, which is gig 101. We say no switch port. Hit enter. Then IP address to be this one is 90, 96. Now it will be 97. I'll paste this one and include 97. Then we have 255.255.252. Exit. Do right. Then finally we move to this layer 3 interface, which is gig 01. Okay. Gig 01 also. So I come here and click gig 01. No switch port. Okay. Then IP address to be, I'll paste that one, is this is 92, meaning now that will be 93. Okay, 93. Then 255.255.252. Exit. Do right. Okay, so let's go to the routers and configure IP addresses. For example, this router here is connected to how many networks? This one. 1, 2, 3, 4, 5, 6. Okay, all the interfaces. And guys, to save time, guys, I'll click on this router and place it somewhere here. Come to config and start. Will it really help? Let me just check. So which interface is this one? Gig, just a minute, gig 02. Okay, and this one is gig 00. This one is gig 00, right? This one is gig 01. Okay. Okay, so I click it, then I start from gig 00. You just click gig 00. Gig 00 is this one. Okay, and the network is, I paste that one there, and the network is this one, 192.168.102.84/30 notation, and this one took .85, so it will take .86, and subnet mask will be 252. Okay, all right. Then we move to gig 01. Gig 01 is this one. Okay, all right. Gig 01 is that one. Gig 01 will take, this one took .81, so this one will take .82, and subnet mask of that one. Good. Then this one is gig 02. Gig 02 will be 192.168.65. okay, .65, and a subnet mask of /28 notation, meaning it will be 240, I believe. Okay, not 240 here, 240. Okay, all right. So let's configure serial interfaces. I'll start with this one, which is serial 020. Serial 020 is, we'll take this one, 89 now. Serial 020 will take 89. Okay, subnet mask of that one. Good. Then serial, this one is just a minute, serial 010, serial 010, serial 010 will take this one, serial 010 will take .5, okay, because this is the network. It should be 252. Okay, good. All right, so let's move to serial. This is the other one, serial, this one, serial 021, serial 021, serial 021 will take .1, okay, because it is 0, so that one, okay, so that's right. Do right. I believe we have configured the right interfaces with the right IP address. Okay, so let's go to this router here, which is connected to how many networks? 1 2 3 4 5. Okay, so I will start. We'll start with this interface. Which one is this one? Gig 01, gig 00. Okay, so start with gig 00. Click here. Let me do this. This is gig 00. Okay, so gig 00 will take this network. Gig 00 will take .4 because .3 was taken by this interface. .4, okay, a subnet mask of 252. Okay, then this one was gig 01, believe so. Yes, gig 01. Now gig 01 will take .98. 98 subnet mask of that one. Good. Then we move to serial interfaces. Which one is this one? Let's start with this one. This one is serial 010. So serial 010 will take this one. Let me just copy. Serial 010 will take that one. Remember, this one took .89, so this one must take .90. 90. Serial 010. Okay, let me confirm again. Yes, serial 010. Now let's go back to this one, which is serial 020. So serial 020 will take this network .9, 0020.9, subnet mask of that one 252. Okay, all right, and finally this one, which is serial 011. Serial 011 will take .13. Okay, because this is the network. All right, so guys, I believe we've configured the right interfaces with the right IP addresses, and I'll move very fast to configure IP addresses to these interfaces of ISP routers. Okay, so this is serial 03031. Okay, 030 will take .2, 252. Okay, and 031 will take .10. 031 will take .10. Okay, same subnet mask, and do right. Okay, and also we move to which one? Also we move to this one finally. So just a minute. Which interface is this one? 020, and this one is 021. Okay, so 020 will take .6 because this one took .5. Okay, subnet mask is 252. Then 021 will take .14 because this one took .13. Okay, and that's the subnet mask. Then do right. Okay guys, so guys, we've done with the step 4, which was about subnetting and IP addressing. Now we've done with step 4, and what we need to do now is to configure OSPF on routers and the layer 3 switches. And guys, to do that, I'll start with the layer 3 switches to move very fast because we have a lot of configuration here. So we start with this layer 3 switch. Okay, exit, config T. Okay, so guys, before we can configure any routing protocol on a layer 3 switch, we need to enable routing on that switch. How do we enable routing on a layer 3 switch? IP routing. Very simple. We are done. Only that. We've enabled routing on this switch. So let's configure OSPF on this switch here. To configure OSPF, guys, we check on how many connected networks do we have. Okay, how many connected networks do we have? All right, so to check how many connected networks, this layer 3 switch here is connected to how many switches? 6 of them, and each switch or each department is expected to be in a different network. So those are 6 plus this one, 7. Okay, all right, so I'll do that very fast. Router, make the router aware it's using OSPF as the routing protocol, OSPF, and a process ID of 10. Okay, then the network be 192.168.100.0. Then I'll just write those networks somewhere. Let me just do it first here. And the wildcard mask of, if this is the subnet mask, what will be the wildcard mask? Very simple, guys. So the subnet mask will be 255.192. So 255 minus 192 will give us 63, right? So the wildcard mask will be 0.0.0.63, area 0. Hit enter, and another network will be this one, 64. Hit enter. Another network will be 128.128. Hit enter. I'm just referencing this one. All of these, okay. All of these, okay. All right. And another network will be 192 now. 192. Okay. Sorry. 192, not 19. 192. 192, like that. Let me check. Good. And another network will be 101 now. 101 and 101.64. Okay, so we have advertised the networks that are connected to the departments. Okay, so let's advertise this network, which is this one. Copy. Another network will be paste there. Then the wildcard mask will be 0.0.0.3. Okay, because the subnet mask is /30 notation. Okay, Very simple. Hit enter, exit, and do right. So we have configured OSPF on this switch. And guys, I need to do something here. I need to configure routing protocols once and for all. There's another routing protocol which is called that you have to configure here, default static route. Okay, so we need to configure default static route here. So IP, just say IP route 0.0.0.0 0.0.0.0. Default static route basically means whenever there is no matching routes in the routing table, then how will that particular route be forwarded? Okay, so I wanted to use we were told to use next op IP address, this one somewhere here. Let me just this one, use next op IP address. Okay, so we'll use the IP address of these routers, which was .82. So I'll just copy this one. Okay, that's a default static route. Copy 82 and hit enter. Good. Do right. Do show IP route. Okay, so we have default static route here, and SPF also. Do show start. Okay, also the content of routing table, as you can see, we have OSPF and default route here. Okay, so guys, we'll proceed to configure OSPF on this router here, and for this router and this router, they are connected to the same network, so they are advertised same networks except this one and this one. Okay, so I'll go back to this router and copy these networks. Okay, I'll just copy this one of them, copy, and I paste here, paste there, then I just remove this one. Okay, so for this router here, for this layer 3 switch, it will advertise this network. So I'll copy this one and replace with the first one, which was this one. Replace with this one. Okay, it will advertise all these networks plus this one. This one will advertise all these networks plus this one. Okay, all right. So it's very simple, guys. And exit, and we come back here. Everything is fine. Now exit, then let's configure default static route IP route 0.0.0.0, then 0.0.0.0 to go through which interface? Next op IP address, which is the IP address of this router, and it will be 86 because this one took 85. Okay, so it's very simple, guys. 86. Good. So we have advertised the networks here and configured default static routing that says any subnet mask, any IP address with any subnet mask, okay, default route should go through this IP address. Okay, very simple. Copy, then I paste this one. Sorry, there's a problem that we've done there. There is a problem here. We've not enabled routing on this switch. Very simple, guys. We could have said IP routing. So let's try to copy again to see if we'll get the same error, config T. So no error because we've enabled routing on that switch. Okay, don't forget to enable routing on multi-layer switch, okay, if you want them to carry out any routing functionality. So also on this side, guys, we will advertise 7 networks for each layer 3 switch. For example, this layer 3 switch will advertise 6 networks plus this network. Okay, so I'll open it. Exit. All right, so let me just write the networks on the notepad. The first network will be, just a minute, 101, 101, okay, 101 dot that one, it's 128, sorry, it's 128. Then the wildcard mask will be, this is 224, 255, 255, 255.224. Then 255 minus 224 will be 31. Okay, so here will be 31. Okay, so the next network will be, I'll just be copying this one and modifying. The next network will be 160. Yes, 160. Then 192, 192. Then 192. Then 224, 224. Okay, and then 102.0, 102.0, 102.0. Okay, then 102. Just a minute. .32. Okay, 102.32. all right, so finally we need to advertise this network, which is that one, and I paste here. Okay, so we have advertised how many networks? 1, 2, 3, 4, 5, 6, 7 of them, right? And also default route, what will change is that just next hop IP address, which will be IP address of this router interface. So I'll just try to check, it's 94, I believe. Good, .94. So we just send this to .94. .94. Okay, right. So what we need to do, just to copy all this configuration to the first switch. Okay, I paste. Good, everything is working. Do right. Then for the second switch, what we change is only this IP address that we are advertising, plus next hop IP address, which will be this one, IP address of this router, which will be, I think it's 98. This one 2.97, so that's 98. Okay, copy. Then we paste to this multi-layer switch. Exit, paste. Okay, all right, do right. So guys, let's configure OSPF on the routers. Okay, let's configure OSPF on the routers. So I'll start with this router, then I come to this router, then I'll finalize with the 2. Okay, so for this first router, it will advertise how many networks? 6 of them. This one, this one, this one, this one, this one. Okay, so I'll open this one again. For layer 3, for a router, we don't need to write this IP routing. Just start from that one. So the network is 102.80. So I'll try to remove this one. 102.80. Then a subnet mask of /30 notation. Now here will remain .3. Then 102.84 also. 84. Here will remain .3. Then this network here, copy, and a subnet mask of let me just use this one here. And a subnet mask of /28 notation. /28 notation is equivalent to .240, I believe so. Yeah, so 255 minus 240 is 15. LB 15. So we have advertised how many networks? 3 of them. Then let's advertise this one also. .88. So what I'll do, I'll copy this and change this to 88. 88. Good. Then the 2, copy, just a minute, copy, the 2, lastly it's that one, .0. So guys, we have advertised how many networks? 1, 2, 3, 4, 5, 6. .84, .80, .0, .4, etc, etc. So also we need to configure static route on this router. And for this network, guys, on this router now we're going to configure 2 default static routing. The first one will be the main one, which is default routing, and the second will be backup default routing. Suppose one link is down, other one will pick up. Alright, so guys, that is very simple. So the first one with that one, then it will use which IP address. Let's say the first one we want it to use these ISPs, and in case this ISP is down, this one will take up. So the first ISP has a IP address of that one. This interface has an IP address of .2 because the router has 2.1. Now that is the main route, the main static route. Now the backup one. Suppose this one is down, this one is down. How will the route that does not match the routing table be forwarded? Let's use this one. So that one will be .6 because this one took .5. And now let's use administrative distance of 70. Very simple. Backup, this is the main. In case that one is down, it will use this one. Backup default static routing. I think you have configured everything the same, right? Then do right, copy this router here. Very simple, guys. You just need to be very keen, know which network you are advertising and how to configure the static routes. Then now on this router also, we are going to advertise how many networks? 5 of them. Okay, this one, this one, this one, this one, this one. Okay, so I open Notepad again and write the networks that we are advertising. So the first one is 102.92, then 102.96, 102.96 also, 96. Everything remains the same. Then 102.88, it's here. Then this one, 1, 2. Okay, this one is not here. 108, 8.8, and this one is dot 12. Everything remains the same there. Okay, so default static route and backup default static route. How do we configure them? We use next hop IP address. So for the first default, our main, the active one, should forward the traffic to this ISP. Okay, and in case this ISP is down, it will forward that traffic to this ISP. So let's use this as our primary path, and this one will be backup path. Okay, so this one dot 13, now this dot 14. Okay, and in case this one is down, it will use this one dot 9, dot 10. Okay, very simple, guys, very simple. I think I have done everything as expected. Exit, then I paste. Okay, all right, so what's remaining here is to I can see all the routers as formed adjacency with the layer 3 switches. I can see that's good news. Okay, good. Can see all of them as form adjacency. For example, these routers as form how many adjacencies? 3. 1, 2, 3. This one also 1, 2, 3. But when we shall have configured this the OSPF on these routers also, this router will form how many adjacencies? 5 of them. 1, 2, 3, 4, 5. Okay, and this one will be 5 also. Okay, so let's configure OSPF here. To advertise how many networks? Only 2. This one and this one. So I go to our Notepad also and advertise only 2 networks, which is dot 0 and dot 8. So this one will be dot 8, and delete this default static route dot 8 and dot 0. Good for this router. Enable config T, then I paste. Okay, then I come to this router to advertise how many networks? 2 also, dot 4 and dot 12. So I just modify here to be 4 and here to be 12. Copy and come here, enable config T, and I paste. Alright, so let me check how many adjacencies have been formed. 1, 2, 3, 4. Okay, because this one has I've just configured this one, so we will wait this one to form adjacency with this router, and there will be 5. So how many are they? 1, 2, 3, 4, 5. Everything is good. And here 1, 2, 3, 4, 5. So guys, OSPF configuration is successful plus static routing. Okay, so let's go back to our guide, which is static IP address to server room devices. So we'll do that one very fast. Also, we're going to configure server room devices to have static IP addresses. Okay, so we've covered from step 0 to step 5, and let's proceed to step 6. Okay, all right, we scroll down to the server site location and assign static IP address to these devices. Okay, remember they have to access this network, which was 192.168.102.64, okay, /28. all right. And as you can remember, our default gateway took .65, so they should take let's say from .66, 67, etc, etc. So I'll start with this one. Before that, I'll copy and assign IP address to these devices, right? Okay, so let's this one take .67, and the subnet mask should be .240 because of /28 notation, right? And default gateway will be .65, and DNS server, let DNS server to be .68, right? So DNS server, copy, that's our DHCP server, right? Then we go to the DNS server, which is this one, and we configure very fast. .68, good. Then this is 240, and this is 65, and I don't need to configure DNS server to DNS server, okay. Then we move to email server. Let it be 69, it's 240. Then default gateway is 65. Then this one is 68, okay, DNS server. Then finally web server. Let it be 70. This is 240. This is 65, and finally DNS server is 68, okay. So guys, basically I think we have configured these devices with static IP address, and I'll go back to our guide to see what's next. Okay, DNS server device configuration. Okay, so guys, as you can see, this device here will be responsible to give or to provide or to allocate IP addresses to all the host devices in the network. Okay, so we'll need to create how many pools? 12 pools, because we have how many departments? 12 departments to be provided IP addresses dynamically. Okay, so we are going to create 12 pools here. So I'll click on this device, then you come to services, then you come to DHCP, and you turn it on first. So you create pools. Okay, so for example, we have a pool, we create pools as per the departments. Okay, for example, this is MLOCS. Okay, so we create a pool, just a minute, MLOCS pool. Okay, and the network will start from 192.168.100.0. okay, that is default gateway. Now let default gateway to start from .1. okay, right, and I copy. DNS server will be, it will be 192.168.102.68, I believe so. That was DNS server that we configured just few minutes ago. Yes, so that's our DNS server. Okay, and we want this we want the DHCP server to start providing IP addresses in that pool from, let's say it's 100 from .6. okay, and the subnet mask is .255.255.192. okay, and the host, let's say it's 60. Then you add. Okay, now we create another pool also that is called MER. We create another pool MER. Yes, create another pool MER, and the pool starts from .64. now that's the network. Now IP address of the default gateway should be .65. Good. And this is the DNS server, which is unchanged, and now it should start giving IP address from, let's say, .70. okay, and the subnet mask remains the same, and we add. Okay, all right, so let's move to the other pool, which is MRM pool. And MRM start from .128. now then the IP address of default gateway should be 129. okay, and we want to start giving from 134 or 135. let's just say 135. okay, no problem, and we add. And now we go also to which pool? IT department. IT department should be IT department. Just a minute. IT department. okay, so the network start from 193. I mean IP address of the default gateway should be 193. okay, and I want it to start giving from 196 or 197. okay, all right. And sorry, MRM, we say IT department, sorry, IT pool, and you add. Let me check it again. IT pool, that's correct. Then we go to CS pool, which will be .101.1. okay, then everything remains the same. Then this one start from .6, 101.6. okay, everything remains the same. Sorry, this call is CS. I'm forgetting too much. CS pool, then we add. Then finally we configure which pool? Guest or waiting area pool. Then I change here to guest or waiting area pool, which will start from .64, now .65. okay, and I want it to start from giving from .70, and we add. okay, so we have added all the pools on this side. okay, all the pools on this side, we've added them, 6 of them. So guys, I'll go back to this side and add these pools. There are the remaining 6 pools, and I'll do it very fast since we've done it on that side. Sorry. So another pool is NSO pool. NSO pool should be 101.129, and I want to start from giving 130, let's say 135. okay, and you add. And this is HL, which is Health Hospital Labs HL pool. It should be, sorry guys, let me just do this one first, then we come back to NSO pool. okay, for HL pool, then 160, say 160. okay, and we want to start giving from 165. Sorry, so this should be 161. okay, and this one should be, let's say, 166, right? And now the subnet mask should be 224 because plus 27 notation, right? HL pool, this one is right, here is right, here is right, and we add. okay, right, so we go. So let's proceed. We go back to NSO pool that we made some little errors. Is 129, that's correct, this is correct, this is correct. Now we change this one. okay, subnet mask, and you just click on save. all right, so guys, let's go to HR pool. HR pool should be 193. Okay, 193, and I want to start giving from 196. Okay, and here, and now let's go to marketing department, finance, and guest waiting area. Okay, so we go to marketing. MK is 224. Now that will be 225. Okay, everything remains the same. Now here becomes let's say from 230. Okay, and just for MK department it's correct, then we had that one. Okay, so we move to, you already added MK department. Now we move to finance, which is fin, and now for finance start from 102, then dot one, and here should be 102, and let's start giving from dot 6. Okay, everything remains. Then we add finance department. Then finally we go to guest area. Okay, should start from 32. I mean, now that is 33, and let's give it start from 37. Okay, and everything remains the same, and we add. So guys, basically I think we've added all the pools that we need to have in this topology, and now we can proceed to go on with other configuration. So I'll just go back to our config guide and configure inter-VLAN routing on layer 3 switches plus IP DHCP helper address. Okay, so guys, that is very simple. What I'll do first, and before I can configure inter-VLAN routing on the layer 3 switches, guys, I want to mention something here. Remember, we've configured VLANs on this switch. Okay, and for this VLAN to communicate with other VLANs, then we must carry out inter-VLAN routing, and to carry out inter-VLAN routing for this VLAN, we must do it on this router. Okay, and to do it on this router, then we have to use a sub interface of this interface to be the default gateway of this one. So which interface is this one? This is gig 0/0. So gig 0/0, this one. Okay, we should create sub interfaces of this interface. So the first thing that we must do first is to remove IP address to this interface first that we assigned earlier. So let's say no IP address. Okay, and let me go here and check again. So there is no IP address there. Okay, now let's create sub interfaces. Sub interface. Now interface gig 02 dot, which VLAN is this? This is VLAN 70. Okay, so we just say .70. Okay, all right, now we just say encapsulation .1Q70. Okay, then we assign IP address that we already assigned to this interface here. It was 192.168 12.168 dot, let me just check, it was 102.65, I believe so. 102.65, the IP address that we initially signed here. Okay, .102.65, subnet mask of 255.255.255.240. Okay, and we hit enter, exit, and do right. So we have configured inter-VLAN routing on this router to enable this VLAN to communicate with other VLANs in the network. Okay, all right, so I think if I can just do this, can just try to ping the default gateway, ping 192.168.102.65. and as you can see, everything is working. So what I'll do is to proceed to configure inter-VLAN routing on the two switches. Guys, inter-VLAN routing on the two switches will be the same because they are just connected to the same networks. Okay, so for example, I'll go to this switch, exit. Remember, we've created how many VLANs? We've created several VLANs here. Do show VLAN. See, 10, 20, 30, 40, 50, 60. Okay, so how do we configure inter-VLAN routing? Interface VLAN 10. Okay, then you assign IP address to this interface. Remember, we created VLAN 10 earlier. Okay, and for VLAN 10, the IP address should be 192.168.100.1. this one. Okay, for this VLAN. Okay, department I mean. Okay, 255.255.255.192. okay, then IP helper address, sorry, IP helper address should be IP address of the server, DHCP server, which was this one. Okay, copy, close this one, okay, we paste and hit enter, exit. So we've configured inter-VLAN routing for this interface and provided a way to access the DHCP server. Okay, all right, so let's move to VLAN 20, interface VLAN 20. Do it very fast. Then we'll send IP address of now that will be 65. Okay, then IP helper address to be that one, exit. So guys, let me just do it on notepad so that we can go very fast. Interface VLAN 10. Okay, then we copy this IP address, copy IP address, then we say IP helper address, this one, copy that one. Then we move to interface VLAN 20, 30, 40 until 60. Okay, that's now 20 should be .65, and then 30 should be .129. I mean 129, I believe so. Good, everything remains the same. Then 40 should be 193. Good. Then 50, let me just copy this one, copy. 50 should be, let me just check again, 50 101.0, 10 should be 101. Just a minute. So this one should be 101, 50 should be 101, 101.1. Now everything remains the same. Then 60 should be 101.65, 101.65. okay, then you copy all of these to the two multi-layer switches. I paste here. Okay, then do right. I move to the other switch also to paste the same, this one. Okay, Okay, so let me do it very fast to save time. Exit and paste. Alright guys, so do right. Then let's go back to this side to configure inter-VLAN routing for the two multi-layer switches. So here guys, let me take it up a little bit. So here we'll need VLAN, start from VLAN 80 until VLAN 130. So it's VLAN 80, then this is 90, this is 100, this is 110, this is 120, and finally this is 130. Okay, then for VLAN 80 IP address should be .129, so I'll just copy this one, .129. So this one should be .129, 129. Okay, and this one will be, and now here subnet mask should change because it's .224. Okay, so here also should be 224. So what I'll do, just copy this, and I paste here. And for VLAN 90 it should be, let me just check, 161, right? 161, just a minute, 161. Then this one also I paste. Then this one will be 193 for VLAN 100, I believe so. As you can see here, VLAN 100 will be 193. Now VLAN 110 will be 225. VLAN 110 will be 225. VLAN 110 will be 225. This is 225. Then VLAN 120 will be 102.0, 102.1, sorry. Then subnet mask should be 224. Okay, then finally VLAN 130 should be 102.33. Copy, then we paste to the two multi-layer switches. I believe I've configured everything the way they should be. Okay, so click on this one, come to config, exit, paste, do right. Then I come to this switch also and I do the same. So I need to do right. Okay, so guys, basically I think I will test our configuration, and let me start with this PC. Come to desktop, this one, then DHCP, then I go to this one also. I come to desktop, IP, then DHCP. So I will go up and try to test if they have picked IP address from this server. Okay, I use this PC, so let me hover. As you can see, it has picked IP address. As you can see, it has picked IP address, and default gateway is this one, right? So this one also, it has picked IP address, and the default gateway is this one. As you can see guys, everything is working as expected. And now what about MRM Hoover? As you can see, it has picked. Okay, what about IT department? As you can see, it has picked IP address. And now let me scroll again to CS and guest area. As you can see guys, everything is working as expected. pretty much simple, guys, and very interesting. As you can see, guys, everything is working. So also I'll click on this and take DHCP. As you go up, let me hover. As you can see, guys, it has picked IP address in that range. This one also, it has picked this one has not picked IP address. Let me check this one again. This one has picked. Let me try to check which problem is. This one has problem. Let us try to request again. It has picked now, as you can see, 102.7. okay, and the subnet mask is that one. And what about this one? This one has not picked also. I'll try to request again. It has now picked, as you can see, 101.230. okay, all right. So this one also, let me try to check. It has not picked, but now it has picked. What's wrong? When I click them now, they are picking. As you can see, it has picked. When I try to hover it, you'll see it has picked. Also this one has picked. Okay, now finally on this one, let me try to check. It has picked. It has picked. Alright, and what about this device? Smartphone has picked. Good. So guys, basically I think that step is done. Now I'll try to go to the other step, to configure wireless devices. Guys, for the wireless devices, I will do it very fast to save time. I will configure one device, and for the remaining devices I will do it very fast to save time. So let me try to configure this access point, the first one. Okay, click, come to config, then I take this name, come to port 1, then SSID will be that name, and password, let's use WPA 2 PSK, and let's just use that 123. okay, all right. So okay, so that's the password and the SSID. For laptop, how to configure laptop to a Wi-Fi? You turn the laptop off first, then you remove this Ethernet module and you replace with a Wi-Fi module, this one, WPC 300N. okay, then you turn it on again. Okay, now you come to desktop. The device must be powered on. Okay, you turn it on again, come to config wireless, and input the SSID, come to the password, then the password was 123. We close, then you come to the smartphone, come to config, come to wireless, and put the SSID, and the password will be that one, 123. okay, so let's check if it will connect. As you can see, the laptop has connected, and let's wait for the smartphone to connect also. So meanwhile, I'll connect other devices very fast, guys, to save time. Okay guys, so as you can see, we have configured wireless network for every department. Okay, and as you can see, every device is connecting to each access point at every department. So even on this side also, you can see every device in every department is connected to that particular access point. So guys, I think that's successful. And if you check on the IP addresses, and you'll see the laptop has picked the IP address in that department. And also when I try it on this PC, you can see a printer, the same. Then I come to the second department, the same, the same, the same. Okay, so etc, etc. If I can randomly select them, let me try on the last department on the main hospital. You can see everything has picked IP address. That's good. So I'll try to go to the branch hospital to check if the devices have picked IP addresses. Okay, so if I try on this first department on the branch network, you can see it has picked. Even the wireless device, it has picked. Second department, let me try printer. You can see a printer has picked IP address. Wireless device, it has picked. Okay, and just randomly select them so that we can save time. Okay, even the second last one, you can see every device has picked IP address. Okay, alright guys, so basically what I'll do, I'll go back to our config guide so that I can show you what so that we can see what's remaining to be configured. Okay, so in our config guide we have 3 steps that we've not completed: set to site VPN, default static route, and port address translation plus access control list. But I have realized that we've configured these earlier. Okay, so we're just remaining with site to site VPN and port address translation plus access control list. So guys, basically I want to configure NAT plus access control list before I can configure this one, because there's something that I want to demonstrate. Okay, then we finally configure IPsec VPN, right? So guys, let's go proceed to our topology and configure part plus access control list. So I'll just go back to our topology. Okay, so this is our topology guys, and we need to configure NAT. We're going to configure NAT on this router and on this router, so that the private IP addresses both on the HQ network and the branch network can be translated into a public IP addresses using this router. And which method of NAT? Port address translation. Okay, so we're going to configure port address translation on this router and on this router. Okay, alright, and let's analyze it also. When we want to configure port address translation, we need to overload an interface. Okay, for example, this router is connected to 2 ISPs, this one and this one, also this one and this one. So this router is connected to the 2 ISPs using which interfaces? This one and this one. So these are the interfaces that we are going to overload. Okay, this one and this one that are connected to the ISPs. Also when it comes to this one, it's this one and this one, and they're going to be NAT outside. This one is NAT outside, this one and this one NAT outside, but this one NAT inside. Also this one and this one NAT inside. We are not going to configure NAT on this interface, the direct one, this one and this one. Okay, alright, just this one, the IP NAT inside, and this one IP NAT outside. So guys, we should start configuring NAT on this router. I'll click on the router and come to config. I don't want to put a password because if I go that way I'll put password, so I'll just come config and something like this one. Then I come back and I exit. Alright, so guys, I need to identify which interfaces are this one. This one is, just a minute, serial, just a minute, serial 010, and this one is serial 020, and this one is 020. This one is just a minute, 021, and this one is 010. Okay, so interface 021, I just come here to config, then I say 021. The first thing that I need to do, guys, this interface has a clock rate. Okay, I mean, this interface is a serial DCE interface, and we need to configure clock rate, and that's the first configuration that I'll do before I can configure PAT. I'll make sure that I configure clock rate to all the DCE interfaces. Okay, if you hover over this interface, you'll see something like a clock. Okay, that's a serial DCE interface. That one also a DCE interface, and this one also you'll see something like a clock. That's a DCE interface. But when you come to this router, this one is not DCE interface because the one side here is DCE interface. So when you move over this one, that has a clock, and this one has a clock. So on this router, guys, all these three interfaces has a clock, DCE interfaces, I mean. Okay, but on this router it's only this one and this one. So the first thing that I'll do is to configure clock rate to all these interfaces. Okay, so just click on the router and you just come to config to save time. So I will start with this interface, which is serial 020. I come to serial 020, I click on serial 020, then you set clock rate to be, let's say, 64,000. Okay, all right. Then you come to the other interface, which is this one, which is 010. You have to carefully check if all of them has clock on the interface. Okay, all right. Then finally on this interface also, which is serial 021, clock rate should be 64,000. Okay, very simple, 64,000. Right, then you come to CLI and you say do right. Okay, so we are done on that. And what I'll do, I'll configure clock rates on this router also, because it has a DC interface on this one. As you can see, there's something like a clock. Okay, this one also clock, but this one is not clock. Okay, all right. If you can check it clearly, it doesn't have clock. So this one is 02, just a minute, 020. Yes, and this one is 0, just a minute, 011. I'll just do this, guys. I'll go to options, preference, and always show port, that one, and I close. So if you look at it clearly, you'll see these interfaces have clock. Okay, so it's serial, just a minute, it's serial 020, and just want to see the other one, and serial 011, 20 and 11. So I'll configure clock rates to that interfaces to serial 020. You come to clock rate, you set to 64,000. Okay, then you come to serial 011. Okay, also you set to 64,000. Okay, all right, very easy. Then you come here and you say do right to save, and I close. All right, so guys, we may begin configuring PAT, and before that I'll just close the interfaces. I'll just say that one, right? All right, so if I try to hover, I'll just do it again, show port labels. All right, okay, so let's start configuring PAT. I'll start on this router, so I'll check which interface is this one. This is 010. So I'll say exit interface serial 010 IP NAT outside. Okay, and the other one also is this one, 021. Okay, interface 021, serial 021, a peanut outside, exit. So as we said earlier, guys, this interface and this interface will be IP NAT outside, but this one, and this one IP NAT inside. So I'll just try to check this one, gig 01, gig 02, and gig 00. So it's from gig 0, it's from gig 0 to gig 02, IP NAT inside. Okay, interface range gig 0/0 to 2, IP NAT inside. Okay, exit and do right. Okay, so we have identified this one, and this one, IP NAT inside, but the two to have to be IP NAT outside. Okay, so guys, let's create an overload interface. Just say let's bind it to an access control list. Access, sorry, before we can configure access list, let's say IP NAT inside source list 1, then interface to be the two interfaces, this one and this one. Okay, it will be this one. I'll just say this one, copy, and I paste. Then you say overload, hit enter. Then another interface will be this one. I copy and I paste. Okay, and do right. Okay, so guys, basically what's meaning is to configure access control list. Remember, we've created an access control list 1 within this number, and we've bound it to a NAT. Okay, how do we say it? We've created a bind between the NAT and access control list 1. Okay, so let's create access control list 1 and permit the IP addresses that we want. Okay, so we proceed to access list 1. Okay, then permit. So we start. We have how many networks here that we want to permit? We have 6, I think. 1, 2, 3, 4, 5, 6. Okay, so we need to permit all of these networks. The first network is 192.168.100.0, and the wildcard mask of /26 notation is equivalent to a wildcard mask of 0/0/0 dot /26 notation is equivalent to 255.255.192, meaning it's equivalent to 63. Okay, so 255 minus 192 is equivalent to 63. Okay, then I hit enter. That's then another rule will permit /64.64 with the same wildcard mask. Then another rule should permit 128 with the same wildcard mask, and I scroll back down. Another rule also, should permit .192 with the same wildcard mask. Then another rule should permit so here it's 101, it's 101.0, so I'll just modify this one, 101.0. Then another rule should permit 101.64, with the same wildcard mask. Okay, 64, right? Alright, so guys, we permitted how many IP addresses? 1 2 3 4 5 6 network addresses. Okay, 6. Alright, so we're done here. Do right. Okay, so what I'll do, guys, I'll just try to say do show IP NAT translations. There's nothing yet. Okay, so let's verify that. I'll come to this laptop here and I'll try to ping. Let's say this ISP IP address of that ISP, which is 195. I'll just try to copy it. I'll just try to ping IP address of this ISP route. I'll copy it and ping it from which device, any of these, even this PC. Okay, and I come to desktop and there and say ping. Okay, and I hit enter. Just give it some time. As you can see, it's pinging. It's pinging successfully. Alright, so after pinging, guys, I'll just go back to the same router and apply and issue the same command that I've just issued. This one. Remember the first time I tried to issue it, there's nothing that came up. But when I try to issue it again, can you see? We have inside global, inside local, which is the IP address of this PC, but inside global is the inside global is the translated IP address. Okay, outside local and outside global are the IP address of the router that you just pinged. Okay, this one. All right, those are outside global. So guys, NAT is working on this router. Let's go here and configure part the same way we have done here. So I'll go very fast to save time. We've said this one IP NAT outside. Okay, this one and this one will be IP NAT inside. Okay, all right. So I click. All right, exit. So before that, let me check. So we check this one is serial 011 and this one is serial 021. Okay, so I'll go here and say interface serial 011 IP NAT outside. Then another one is serial 02. Let me check again. This one is serial 020. Okay, 020 IP NAT outside. But this one gig 01 and gig 00 are interface IP NAT inside. Okay, so interface range gig 0/0 to 1. Okay, IP NAT inside. Okay, exit and do right. Okay, so let's start to configure the overload interfaces. So IP NAT inside, source to be list 1, access control list 1, and the interface to be overloaded is this one. Let's start with this one. Copy and I paste, and you say overload. Another interface will be serial 020 overload. Okay, and do right. Okay, so let's create access control lists, access control list 1, and permit and create rules to permit certain IP addresses. Okay, all right. So here we have how many IP addresses? We start with this one. Okay, so let's say access list 1 permit 192.168.101.128, and the wildcard mask of this has a subnet mask of /27. /27 is equivalent to 255.255.224. So 255 minus 224 is equivalent to 31. Okay, so it's 0.0.0.31. Okay, then another IP address that we need to permit is .160. Another one is 192. Same wildcard mask. Another one is let me just scroll 192. Then we have 224, 224. Another one is 102.0 and 102.32. So I do that in very fast. 102.0, 102.0, 102.0, and 102.32. Okay, so we've just permitted how many IP addresses? 1, 2, 3, 4, 5, 6. Good. Then do write. So do show IP NAT translation. Nothing yet, as you can see, guys. So I'll try to ping this router, any IP address of this router from any of these PCs. Okay, so let me take IP address of this router, come to config, any of it, either that one. So I copy that, and I come to any of this PC. Even a laptop, let me just now use a laptop in this case. I come to desktop and ping, and I paste, hit enter. Just give it some time to see if it's ping, so that we can verify our configuration. As you can see, it's pinging successfully. So guys, after this one, we'll go back to the same router and issue the same command to see if any translation has occurred. Okay, all right. Okay, so if I can go back to this router here, the branch router, and click so that you can verify if NAT is configured correctly. So, and I issue the same command and hit enter. As you can now see, the IP addresses have been translated successfully. You can see inside global, which is the translated IP address. You can see inside local, which is the IP address of this laptop here. Outside local and outside global are the IP addresses of the destination, which was the interface of this router. Okay, alright guys, so basically what's remaining is just to configure site-to-site VPN. And how are we going to configure site-to-site VPN? We're going to create a tunnel between HQ network and branch network, okay, so that all the traffic from HQ to branch network are encrypted, and all the traffic from branch network to HQ network are also encrypted. So allow me just to do this thing. I'll just try to draw something, and I'll select fill color, select, and let's say something like yellow, or even let's use that color. Okay, and we want to create a tunnel here. Okay, so we want to create IPsec VPN tunnel there. I'll come to text and I'll say IPsec VPN. Okay, and I'll say site to site VPN tunnel. Okay, alright. So guys, we want to create tunnel here between these two routers, okay, so that all the traffic from on this side can be encrypted when they are going to this site, and all the traffic from this site can be encrypted when they are going to this site. Okay, and we're going to use which mechanism? IPsec VPN, site to site IPsec VPN. Okay, alright. So that's very simple. What you should do when you're configuring IPsec VPN tunnel, the first thing to do is to include the activate the security modules on the routers. So before that, I'll just draw another setup. Let's say just yellow, so that it can be visible. Let's do something like that. Okay, so we want to create a site-to-site VPN between these two routers. Okay, alright. So I'll just go back to our config guide. What's remaining is just this one, site-to-site VPN, and to verify and test the configuration, guys. So let's start from site-to-site IPsec VPN. Alright. So the first thing to do is to enable security technology package on that router. For example, on this router, I'll just click on this router, and I don't want to put password, so I'll just come to config that one and exit. How do you enable security technology package on this router? Do you just say license boot module C29, that one, then technology package, and you say security K9. Okay, with this command, guys, you shall have enabled security technology package on that router. You just hit enter and you say yes, and you let it to reboot, and you just say do reload. Okay, yes, and you come to this router. Remember, we want to configure IPsec VPN on this router and on this router. So come to this router and just say exit. Just say license. You enable security technology package on that router. License boot module, and this router is C2900. Okay, and technology package to be security K9, and you hit enter. Yes. Okay, and you say do reload. Okay, yes. Alright, so guys, the first step is done, which was to enable security technology package on the two routers. Okay, so the second thing is to configure access control list on the traffic that we want to be encrypted. Remember, we want all the traffic from HQ network to be encrypted towards branch network, and also all the branch traffic to be encrypted towards HQ network. So all these networks will be encrypted. So we create an extended access control list and permit the number of IP addresses that we want to be encrypted. Okay, for example, let me click on this router. We are going to create a lot of rules, because a single IP address, a single network here, we want it to access all the 6 networks. Okay, so one network on this side will be accessing 6 networks. Those are 6 rules. Another network, 6 networks, 6 rules. So it's like we're going to create how many rules here? 1, 2, 3, 4, 5, 6 times 6, 36 rules. But we can do route aggregation or route summarization so that we can create 2 or 3 rules. Okay, For example, we can aggregate this IP address plus this IP address plus this one plus this one and this one into one IP address. Route summarization, okay, so that we can just create a single route rule instead of 36. Okay, alright. And also on this side, guys, we can summarize this route, this IP address with this one, and with this one, so that we can create a single IP address, which is called route summarization. Okay, so basically, to save time, I have done that on my free time. So let me show you how I have done it. So here are the summarized routes. For example, we have summarized these IP addresses, the first 4 on the HQ network, into one IP address. Route summarization here should be 0. Okay, and the remaining 2 into another one. Okay, right? Okay, so here should be 4. Sorry, here should be 4. 2 4. So we have summarized this into one IP address, which is this one, and these 2 into one IP address, which is this one. Okay, right? So if you calculate the number of hosts here, you'll get it's 256, and this subnet mask will satisfy that. But if you calculate the number of hosts here, you'll get as 128, and this will satisfy that. Okay, and when you come here, guys, on the branch network, now we have summarized all the IP addresses into this one. If you calculate the number of hosts in all these, you'll get it's around 192. Okay, and this one will satisfy that, right? Okay, guys, so let's create access control list on the 2 routers. Remember, on the SQ router, we're going to create how many access control lists? 2. I mean 1 consisting of 2 IP addresses. Okay, alright, so I'll just go that I'll go here very fast, then I come to config, I come to CLI, it needs password, I come back to config, that one, exit. Alright, so let's create an extended access control list, access control list 110, let's say 110, then permit IP, the aggregated IP address, which was this one. Okay, alright, 192.168.100.0, a wildcard mask of 0.0.0.255. remember, it was /24 here, right? Okay, and then this IP address should access aggregated IP address on this side, and the aggregated IP address on that side is this one, okay, is this. I'll just copy and try to paste so that I can save time. Okay, it should access that IP address with which subnet mask, a wildcard mask of 0.0.0.255, because it was /24 notation. Okay, alright, so that's the first rule. Hit enter. The second rule should be this, the second aggregated IP address should access this one also. Okay, alright, so I'll do that very fast. The second aggregated IP address is this one. I'll just copy, and I come and I retrieve, and now I go back and change this, I paste the IP address there, and with which subnet mask, /25 notation. So /25 notation is equivalent to 0.0.0.127. okay, and you hit enter. Do right. So guys, we've created the access control list on SQ router, and we have highlighted IP addresses that should be permitted during IPsec VPN. Okay, so any traffic matching that aggregated IP address should be encrypted. So I'll come back to this router here, which is brand router, and configure the access control list. Exit. So access control list, let's say 110. Okay, then permit IP. Which IP address should be permitted? This one, the aggregated one, which is this one. I copy, then I paste here, with which subnet mask 0.0.0.255. Wildcard mask should go through which IP addresses? This one and this one. So the first one I'll take, I'll copy, and I paste, and the wildcard mask 0.0.0.255. Another one should be this one now, 101.0. So I'll change this one to 101.0, 101.0, and the wildcard mask of slash, this is slash 25, which is equal to .127. Okay, hit enter, exit, and right. Alright, so we have created access control list as required, which is the first phase of configuring IPsec VPN. We have to highlight the traffic that we are interested in to be encrypted, and we have just created right now this one. Okay, alright. So the second phase, guys, is to create internet key exchange. Okay, internet key exchange on both routers. Internet key exchange phase 1 for internet security association key management protocol, which is ISAMAP. Okay, so I'll do on this router and on this router. Okay, so I'll start with this router. I'll just say crypto ISAMAP policy. Let's create a policy. Let me just query a policy with the number 10. Okay, alright. Then we specify the encryption algorithm, which is encryption. For the case of IPsec VPN, we use ASA. Okay, with the length of 256. Then let me query. Okay, that's okay. The first thing we do is to create internet key and exchange phase 1 using ISA KMP. Okay, with the policy number of 10. Then we specify the encryption algorithm, which is ASA 256, length of 256. Okay, bits. Okay, alright. Then authentication, we specify the authentication to be, let me query, to be pre-share. Okay, alright. And also, and now we give it a group. We can give it any number. Let's say group 5, which is a Diffie-Hellman group 5. Okay, for authentication pre-share between the two devices. Okay, then you hit enter, then you exit the interfaces. Now we match it to the peer IP address, which is crypto. We use crypto. We say command crypto ISAMAP key. I query. Let's use the password of the key should be, let's just say VPN 55. You can use anything. I've just guessed that one. Then address should be the IP address of the next router, the router that we're going to configure IPsec VPN. So when we're configuring IPsec VPN here, the next peer should be, the IP address of the peer should be IP address of this router, okay, which is so this was 192.102.88. So I'll copy this one and try to check which IP address belong to this one. So it's .102.90. So I click this one and I paste that there, then I change this one to 90. Okay, alright, I hit enter and do right. So we have created IKE phase 1, Internet Key Exchange phase 1. So guys, we need to create Internet Key Exchange phase 2. So we're going to create a transform set for VPN. So we just say crypto IPsec transform set, then I query. Let's say, which word can you use here? Let's just say VPN set. Okay, then we match it to ESP. Let's query ESP AES encryption algorithm. Then we use ESP SHA. Okay, so I think that's okay. Then you hit enter. Right, now we're creating IKE phase 2. So now we create a crypto map, okay, to bind all the phase 2 configuration that we just done. So we just say crypto map. Let's just say map VPN map. Okay, and then remember we created a policy number of 10. Then we say IPsec ISA KM. Okay, alright. Note the nuke will be remain disabled until appear or have been modified. Good. So guys, we proceed with our configuration now. So we give it a description. Let's say it's connects to this VPN connects to branch network. Okay, and hit enter, and then set peer to be set to be the IP address of this router. Okay, this one, right? So I think I copied it was .90, and you hit enter. Now you set transform set to be, let me just query, let's say VPN set. Okay, hit enter. Then this one should match our access control list number 110. Okay, exit. Alright, we need to configure crypto map on the outgoing interface. So we want to use this one as our outgoing interface for IPsec VPN. Okay, so we need to configure crypto map on this interface here, which is serial 020. So I'll just go directly here and click on serial 020, then and I configure crypto map for the outgoing interface, which is very simple. So just say crypto map to be what we created, VPN map. Okay, alright, exit and do right. So guys, to check the configuration, we just say do show IPsec, do show crypto IPsec security association, and hit enter. And as you can see now guys, there are some parameters here: packets encapsulated 0, packets decapsulated 0, and everything is just 00. But when we try to ping from this side to the other side, you will see a change here. Okay, so let's proceed to configure IPsec VPN here, guys. Remember this process takes a lot of time of configuring IPsec VPN, and I have already prepared some codes through which I'm just going to paste on this router, because I've showed you how to configure IPsec VPN on this router. So I'm just going to paste those codes here so that we can proceed to test our configuration. Okay, alright, so let me open it, the codes. Okay, so these are the codes for IPsec VPN configuration for the second router. As you can see, the first thing we created was a policy number 10. We created the first phase of internet key exchange, then a policy of 10, and we specified the encryption of the algorithm of AES, okay, then authentication to be pre-shared key, then a group of 5 features Dell Fman. Then for the second, we need to set the peer. Okay, now the peer here should be a peer desk bridge router, this one. Okay, and also other configuration that we've done on that side, and now that's okay. Description, this is HQ network. That case, is this interface really 2.0? That one is 0.1.0. So I'll just change this one and paste everything the way they are on that router, and we shall have configured IPsec VPN on this router too. Config, and I paste everything. Do right, exit. Now do show IP, do show crypto IPsec security association. You can see everything there 0000. So guys, basically I'll try to ping from any of the PC. Let's say the IP address of this laptop is 192.168.101.171. okay, 101.171. So I'll try to ping from this laptop here, which is the IP address is 192.168.101.171. sorry, and I hit enter. Sorry, ping. Okay, so let's just give it time. It will take time because the encryption and all the rest, but it will definitely ping. Okay, so it's pinging. As you can see, first packet has gone, the second packet has gone through, the third might fail, and the fourth will go through. Okay, so if I try to ping again, you see it's now pinging successfully and everything is working. So I'll go to these routers again and try to test IPsec VPN. Okay, remember the purpose of configuring IPsec VPN is to encrypt all the traffic from HQ network to the branch network, okay, and vice versa. So when I try to issue the same command here, remember the first time I issued this command, here was 0, here was 0, meaning no packet was encapsulated, no packet was decapsulated, So let me just hit enter again. Now you can see 7 packets have been encapsulated, 6 packets has been decapsulated, and we sent some values here as errors is 1. Okay, now go to this route again and issue the command. You can see here is 0, here is 0. Okay, and issue the command again, and you can see 6 has been encapsulated, 7 has been decapsulated. Okay, so I'll try to ping again from, let's say, let me take IP address of this laptop here, which is 101.70. So 101.70, I'll try to ping from, let's say, from this laptop also, which is on the branch network. So let's say ping 192.168.101.70. So let's just give it time so that it can ping. Okay, and we see if it's working. Alright, so let me check. It's still not working, so I'll just give it some time. Okay, you can see we have 2 packets has gone through. I'll try to ping again. Okay, so now everything is working. I'll try to issue this command again. Remember, Encapsulated packets are only 6, decapsulated packets are only 7. So and we pinged again, so I'll just issue the same command and you see the value. Sorry, let me try to ping. The value has not increased. Did we really include that IP address in our access control list? So let me try to ping from this PC, which is Sonia. It seems like I never included that IP address in the aggregation. It was not aggregated. 101.70. So that's pinging. Okay, so I just want to check if the value has increased. As you can see now that the value has increased. The total decapsulated packets are 15. Okay, and if I go on this side, originally it was 7 here and 6 here. So you want to see the change. You can see it's now 14 here and 7 here. Okay guys, so I think guys what was difficult here to configure was only IPsec VPN, and what helped me so much was this: how to configure site-to-site IPsec VPN using CLI. So just go to your browser and type this IPsec VPN configuration packet tracer and choose this option of CCNA6ris.com. okay, and you will understand how to configure IPsec VPN. It's very easy, right? So guys, basically I think everything is working on our project, and we have achieved everything as expected in our config steps. Verifying and testing, everything is working. Path and access control list is working. Default route is working. Site-to-site IPsec VPN is working. Everything is working, and I think that will mark the end of this project. And suppose you have any doubt, any comment, or anything that you would like to share, kindly drop a comment on the comment section, and I will get back to you. And let's see you in the next project. So bye, and see you again when we code our 8th enterprise networking project, through which we're going to learn how to configure voice over IP in enterprise networking. Thank you so much, and bye.